We're going to take you to a coffee break pretty soon. But first, a robot. A robot. Showing the robot is the inventor of the robot, a friend of ours and someone who's actually helped with the event quite a bit. Sergei Lupashin studied at ETH Zurich with one of the most famous roboticists in the world, Raffaello De Andrea. He's also introduced us to a lot of people to pull this event together. One of the people he introduced us to, I gave him a call. I said, Sergei sent me. And I talked to him for about 10 minutes. And it was only until about 10 minutes into the conversation that he realized I was not talking about Sergey Brin, the founder of Google. I was talking about Sergei Lupashin, the inventor of the robot you're about to see. And he told me, but I actually prefer that Sergei. And so without any further ado, I'm going to bring that dude's favorite Sergei and the inventor of a really cool technology called the Fotokite. Ladies and gentlemen, Sergei Lupashin.
That has to be the strangest introduction I've ever received. Thanks for that. I have here a box, and I'll open the box. This is not a J.J. Abrams talk, but give me a second. First, some context. So I've been working on quadricopters. Can we get some sound? In research, just very similar to Vijay Kumar's talk, research. Okay, so this was a Christmas video. I was working on a lab at ETH Zurich in the Swiss Federal Institute of Technology in Zurich, Switzerland. And basically, we have a similar setup. It's a test bed for controls research. Very important, there are these gray spheres on the vehicles, just like Vijay described. We have a motion capture system, and the type of performance you see here really depends on that, right? So we have the space, a controlled space. There are overhead cameras. They see the vehicles. There are some off-board computers. They are newer than this one, but I like this one. It does some number crunching, sends commands. The robot does some smaller number crunching, or of course, in other research, they do it on board. But the point is, you need all of this external infrastructure to make this type of thing work, which is great for research because you can really skip steps and address some interesting problems. But once you try to make something that works outside the lab, it's a bit of a bummer. It's a bit of a limitation. And at the same time, something that's kind of close to me, I was born in Russia, I'm Russian, is the impact that we're seeing, of course, aerial photography have out there. So for example, this was the Bolotnaya Square protests in Russia and during a recent election, and it's a typical thing that people say, well, is it big or small? Some guys from AirPano just brought their own multirotor. They launched it with an SLR on board, got a few shots, and it's amazing because it establishes the context and it establishes really the scale of things, unlike I think anything else. But of course. That's kind of interesting to look at, right? So what can we do? What do semi-professionals have right now to take these bird's eye pictures? There are a bunch of technologies, of course. My favorite is this one to the right. It's a telescoping mast, basically as low tech as you get. But the point is, they just want the perspective. They don't really care about what kind of technology you use, as long as you get that perspective quickly, safely, and of course, privacy issue. Quite important. So we kind of looked at this and we juggled a few ideas and tried to kind of integrate our experience into this. And we came up with what I hope is kind of a different approach. And think of it as a complement to the existing things out there. I'm opening the box. It's a big moment. Okay, so on first sight, it just looks like a quadricopter. Not very exciting. Maybe you're disappointed. I'm sorry about that. Well, what's really going on here is there's a leash. This is actually a dog leash. And you hear stuff being talked about, personal robotics. I think dogs are pretty personal, and this is a leash for a small dog. Don't use a big dog leash, very important. And the way this works is it's completely self-contained. So I just turn it on. I point it in the direction that I want to launch it. Demo effect, right? And then it flies. And keep in mind, I wouldn't be able to fly it, right, if there wasn't a leash on it right now. So of course, it's very safe. And actually, what you're seeing now behind me, hopefully, yes, is the downlink from this thing. So it's a live video. And you can see it's kind of a flying Steadicam, right? And it's pretty neat, because what we actually did is we took a complex system, and we kind of started removing components and see how do things still work. And we discovered that in this case, if you add a tether as a mechanical constraint and really model the dynamics of this system, you get something pretty cool. The vehicle right now, it's maintaining the angle relative to me just based on onboard sensors alone. There's no radio, there's no machine vision, there's no GPS, obviously. And that's neat, because it's just so simple, it becomes like a flying pet, right? And also, as soon as you have the tether, what's kind of cool to me, I didn't come up with this, people think of it as a pet. So it's the last thing I would say about it. But yeah. And so this is all nice, right? I'm flying it here, but I could just put the camera there. Not very interesting. Oh, let me show you this trick. You can actually use the physics of this system to play around with it. So if I wanted to go further, I just extend the tether, and then I can actually use the inertia to pull it back in. It's just something I like. I like physics. Thank you. So the ceiling here and a healthy dose of common sense prevents me from flying further away. But we did take this somewhere fun to try it out and see how far we could actually push this. Because 8 meters away is not very fun. This is in the lab. It's just hovering. Burning Man, right? So the cool thing about this, it's very immediate, right? You take it out, you launch it. Here, a bunch of people were trying to break the record for the biggest Michael Jackson Thriller dance. Of course, you can launch it up. You can go even higher. So this is about probably 60 meters altitude. Or you can go even higher and capture the sunset. So this is probably around 100, 150 meters. Again, Burning Man, very unique place. You can actually pull these tricks. And the other thing you can do is, well, since it's actually attached to you, you can use the physical constraints of the system and the way it works to your advantage. I'm not sure if you see it, but you can go biking with it, for example. And that's kind of neat because, it's just cool. It's kind of like this bird's eye view. It's following you, and it's following you not because of some sophisticated algorithms, though there are some on board, but not sophisticated sensors or infrastructure, but just because the dynamics of the system implicitly allow it to do so. And I think that we were very lucky. I think it's a gold mine for kind of this hybrid type of personal vehicles that are not free-flying, but somewhere in between. So really in between, the full free-flying drones and the small, tiny drones, but attached to you. And so now we're kind of thinking about this as a flying camera that we can really give to anyone, and they can fly it themselves. And with that, of course, comes an issue of how do you address the privacy, the scalability, the accountability, the legal issues. And I think that's kind of neat as well, because think of this as a kite, right? It's no longer a UAV, a UAS, a drone. It's a kite. It's a kite that happens to have, some pretty fancy wings and control algorithms and things like that. So think of it as a kite. And the cool thing about kites is that you know exactly who is flying this thing, right? There's absolutely no question as to who the operator is. So the thought process here is that if you mass produce something like this, then there's actually an elegant built-in mechanism for also addressing some of the privacy issues and concerns, which I think are completely valid. And I think it could be a powerful tool in the right hands to provide, again, context, scale. Just think of giving this to journalists or giving this to, again, public safety, places where they can instantly launch it, get that bird's eye shot, and so on. And do you want to see the flight again, actually? Just to show you a bit more about the tech, the way it works is there's an IMU on board, It's really a flying cell phone, right? And all you do is the right gyro detects a certain motion. You point it in a certain direction. So let's say I wanted to go straight up instead of towards you. I twist, and there it goes. If we can get the video feed, maybe once it sticks up. And again, what it's doing now is it's maintaining the angle relative to me. So, you don't see much there. And of course, it doesn't matter what the tether length is, things like that. It's kind of cool, right? So the control is all implied. All right, so we call this the Fotokite, and if you want to learn more, just talk to me or visit our website, contact us. Thank you very much.